right, so now we're going to look at another method of finding trig functions of any angle, particularly those that are not in the first quadrant, by using a method called reference angles, okay? And by definition, a reference angle is an acute angle formed by the terminal side of theta and the x-axis. So these drawings will hopefully solidify why we do it this way. So here are some drawings. Now notice that in quadrant 1, the reference angle is the actual angle, so there would be no need to do anything special for that. We kind of already know that. Now looking at quadrant 2. So angle theta starts at the positive x-axis and goes to that side right there. So the reference angle, which I'm going to call theta with a prime on it, is the reference angle. So notice it keeps that same triangle going on there, okay? The reason why it's done this way is, if I call this xy, this would just be negative xy. So it keeps the sides of the triangle the same. So the main idea is that there's angles where the trig functions are just going to be, they're going to have the same ratios, they just might be different in sign. So that's kind of the object of the game here. Okay, if the original point was xy, this is, negative x, negative y, okay? And that means that this angle right here is the reference angle. And if I have this point right here, well, that's going to have the same x coordinate, but the opposite y coordinate, again, keeping that triangle the same, more or less. This angle right here is my reference angle. So let's see how that will work with actual angles. So what we're going to do is, in number 13 here, we're going to sketch the angle 225 degrees, which, okay, so we know it's 90, 180, and 45 more. So this is 225 degrees here. And this means that this angle right here is my reference angle. So there it is. So theta prime is 45 degrees. Okay? So for negative 45 degrees, that's measured clockwise because it's a negative angle. And that means this right here is my reference angle. Okay? So let's take a look at how this actually gets used. So remember that way long ago, we found sine theta, cosine theta, and tangent theta for the angle shown in the figure. Okay? Now what we're going to do is we're going to find sine, cosine, and tangent for the reference angle. So that means for this angle right here, and I'm going to draw a triangle for that. So that's my right angle right there. I know that this is 12, I know that this is 5, and I know that this is 13. So if this is theta prime, I know that sine of theta prime is 5 over 13. I know that cosine of theta prime is 12 over 13, and I know that tangent of theta prime is 5 over 12. Now, if you look back at what we did a couple videos ago, hopefully it's in your notes that I gave you there, these are the same values, just different signs. So basically what it boils down to is that trig functions of any angle boil down to which one does it look like from the first quadrant, and then what sign do I have to affix to it to make it work for the quadrant that it's in. So we are definitely getting somewhere here. Okay, so our steps for evaluating trigonometric functions of any angle. We're going to determine the function value for the reference angle theta prime, and then we're going to affix the appropriate sign to the function value depending on what quadrant it's in. Remembering that sine was positive in 1 and 2, cosine was positive in 1 and 4, tangent was positive in 1 and 3. So it's basically a matter of, do I need the negative or do I not? So let's just take a look at a few examples here. So sine of 120 degrees. So if I sketch 120, that's about right here, which means my reference angle is 60. And G, 60 degrees is a special value, isn't it? 60 degrees means that this side is the square root of 3, this side is 1, and this side is 2. And sine of 120 is going to be the same as the sine of 60 because we are in the second quadrant, and that's going to be the square root of 3 over 2. And there we have it, okay? Cosine of 300. Well, let's take another look here. 300 is all the way around the world except for 60 degrees. And G on that same special triangle, so square root of 3 is opposite to 60. That's a 1 and that's a 2. So cosine of 300 is going to be the same as cosine of 60. Because it's in the fourth quadrant, cosine is positive. Cosine of 60 is 1/2. So cosine of 300 is also 1/2. Looking at tangent of 225. I think I've managed to pick non-interesting examples here. We'll get there. Okay. So tangent of 225. Well, 225 lands us into the third quadrant. This angle is 45 degrees. And G, once again, special angle. 1 root 2. And there again, now one thing we could do is say, well, I know that's -1 and -1. I know that that's going to be -1 over -1, which is 1, because tangent is opposite over adjacent. So here we go. Cosecant, now I'm going to change this to make it something a little bit interesting. I'm actually going to change this to sine of 210. So let's take a look at this. 210 lands us into the third quadrant. It's 180 plus this 30, and G, special triangle, big surprise. I know the side opposite 30 is 1, I know the other one is root 3, and I know that's a 2. Now sine is negative in quadrant 3, so I'm going to put a negative there, and then if I look at the reference angle, the sine is 1/2, and there it is. So it's a matter of finding the trig function of the angle and then affixing the appropriate sign.